Hi everyone. So I wanted to clear up a few things. I was misspeaking yesterday using some terminology, and I told you terminology is really key. So the terminology that I was misrepresenting was I was saying integer data and talking about ratio, but I didn't talk about interval data. So really, I had introduced you to nominal, ordinal, interval, and ratio. And so the interval data is equally spaced apart. It is numerical. And the distances between the scores are really on the same measurement scale, right? So if you have a 90 on an exam, and then if you have another person who has a 90, then those scores are equivalent. Those things are interval data. It doesn't necessarily, hold on one second. Sorry about that. So it doesn't necessarily mean that there is an absolute zero in the interval data. Really, where you're going to find the absolute zero is in ratio data. So the data that we were using yesterday, sodium, there is an absolute zero. So something can have zero sodium in it. And so we were working with ratio data. Also, kind of if you know that you have 100 milligrams of sodium, that's an understood measurement by many communities. Kind of like if you said you had $40 and that $40, you compared it to having $4. Well, $4 is 10 times less than $40. And so if you had 100 milligrams of sodium in one thing and 10 milligrams of sodium in another, you know that there is 10 more milligrams in one compared to the other, or 10 times the amount of sodium in one compared to the other, and 10 times less in one compared to the other. So that is the ratio data. So I misspoke about that. So the data we were looking at was ratio data yesterday. But the one thing I also wanted to touch upon was where question came up around, we talked about paired t-tests, and we clarified what paired t-test means. It means that the two samples are related to one another. But there was also a question about assuming unequal or equal variances. And we went ahead and we actually just assumed equal variances. But since the question came up, I decided what we would do is I could add another test for us to look at. And the test is called the Levene's test. So this Levene's test will actually test for equal variances. So you can go back now and take your two data sets, and you can add this Levene's test before you actually do the t-test. And then it will allow you to justify using equal variances or unequal variances. And so a Levene's test takes a look at and tests whether one group has the same variance as the other group. So in this situation, we can have a mean value. So that's represented by the dashed bar here in these two groups, and that they have different means, but the amount of people or the amount of information that's in there is actually the same. So how do we know that these two things are statistically significantly the same or different? Do they have equal variances? Here, the means are the same, but the variances are different. You see the spreadness of these icons of people is wider than the spreadness Sorry if it's just kind of, I don't know if it's a real word, but I'm just going to use it. So spreadness, how far they're spread apart here compared to how far they're spread apart here. So these are the means, these dashed lines. You can see that these are equally spread apart. Really, they're a copy and paste. So the variance is the same, but the means are different. The variances are different. They're spread apart more. And the means are the same. So our null hypothesis is that they do have equal variances. And then the alternative hypothesis, so H naught and HA, is going to be that they do have different variances. You can graphically look at this by looking at things called box plots and scatter plots. Now, I want to talk about using this website. I think it's a great little website to do some things with, but they use different terminology. So they use something they call the metric scale. So they use nominal, ordinal, and then metric. So they don't use the idea of interval or ratio, but interval and ratio data fall under metric, right? So when they use the term metric, think interval and ratio, right? And if there's an absolute zero in there, then we're going to go with ratio. If there are equal distances, then we can consider using interval data. So what you're going to do is read up on the Levene's test, and then you're going to practice it. I'll give you another website. Unfortunately, the data pack does not have a Levene's test in here. It just allows you to assume equal or unequal. So I'm going to have you log in here, and then you will put your actual data sets or data elements here. So group 1, group 2, you'll clear out group 3, and then you'll calculate, and it will tell you your F figure. And so it's going to be looking at the mean of this group versus the mean of that group. And then it will be calculating your F statistic. And if you want to read about the F statistic, it will help describe what that means here. So for instance, interpreting what the Levene's test data is going to tell you. So you will have here an F statistic. You will have degrees of freedom in one sample, degrees of freedom in another, and it's telling you about that. And then it's going to give you your statistical significance. So this is your p-value, and then this is your F statistic that you would actually describe. The one thing that I want to ask you about is, do you want your Levene's test to be statistically significant or not? So we'll talk about that next time we meet. But I wanted to give you this quick